Hello everyone, thank you for coming. My name is Sean Armstrong, I'm Vice President of Products at Avneta. Today we're going to talk about web applications and specifically how to actually measure the end user experience and performance as applications transition into the cloud. As your companies shift from applications running in your own data centers to those running in public cloud providers, as well as to some degree SaaS providers. There's a lot of considerations to be made here. And in particular, how do you ensure the end user experience of applications that people are used to running locally as you transition to cloud services and as you take advantage of those different cloud services? As you go to containers, as you go to microservices, how can you actually measure the performance available to your application in between all the infrastructure running this code? And how do you make sure that the users that are accessing these cloud delivered applications are actually having a quality experience? We're going to cover that in some depth today. So, as I stated, I'm from Avneta. I'm one of the founding employees of Avneta. We've been in business since 2011. We specifically focus on web application performance, both those that you purchase and those that you develop yourselves and deliver to customers. We're going to talk a tiny bit about that. Then we're going to cover, okay, why is this transition so important? And then things to consider as you make this transition. How do you actually guarantee users are going to have a quality experience as this transition is made? And really a couple key things to look for as you make this transition within your own organizations. So Avneta, as I stated, is all about web application performance. We run a SaaS service ourselves. We are specifically focused on what is the actual achievable performance and user experience of web applications, both those that you purchase, whether that be a SaaS service your business is now using, or a cloud-based delivered application, something you develop and you use internally or you deliver to your users. We run this ourselves in a hybrid cloud environment out of AWS and Google Compute Engine, and we're delivering this for 600 direct customers, about 6,000 indirect customers through some partners we have, and some very, very large organizations. So, for example, Salesforce.com uses us to troubleshoot end-user experience of their largest 1,000 customers for the Salesforce service itself. So if your user is having a poor experience with this web application, it's not always Salesforce's fault. Is it the end user? Is it their network? Is it their ISP not delivering on what they have promised? Is it something within a very complex cloud-delivered network that could be causing poor performance? And this not only applies to SaaS providers, it is also for consumers of SaaS applications. For example, Uber is a large customer of ours. They're expanding quite rapidly. They're adding about three new locations every week, and they are consuming 13 different web applications, 2 of which they develop themselves, 11 of which are SaaS services delivered by different providers. And they need to make sure that at all these different offices, are users having a quality experience? Are they able to do their job productively? And generally, are they happy with the service for both things they've developed themselves running inside of AWS and 11 different SaaS services that they're running on. And they're requiring and relying on Avneta to do this instrumentation for them. Why this is so important is there's a huge transition that really has begun several years ago and continues to really dominate IT spending. As observed by different analysts like Gartner and Forrester, there's a major shift to what's called shadow IT. It used to be large organizations would make software purchases all centralized through IT teams. There'd be some requirements written, money would be budgeted, and IT would evaluate the different providers. They'd purchase some software, they'd run it on a server in their own data centers. That's simply not how the spending happens anymore. 80% of software purchases this year will be SaaS-based. And this transition is also really dominating spending for applications that they've traditionally run in their own data centers. About 6 times the volume of spending will be done on cloud providers than on physical data centers. So this transition just simply makes sense. If you want to really scale up application consumption with your business, going to a SaaS provider and going to cloud providers lets you take something that used to be this huge capital expenditure and now makes it an OpEx spend where you can scale this up with your business. You don't have to lay out all the money up front. And most importantly, you get to choose with your dollars every year. As a consumer of a SaaS service, you get to vote with your renewal. If the SaaS vendor isn't doing a good job, you can honestly move on to another provider. The cost of switching is quite low. And in cloud providers, it's actually becoming extremely cost-effective and with a number of tools available, time-effective to transition between cloud providers as Google and Microsoft really catch up with the one insurmountable lead that AWS had. We've actually transitioned a major portion of the services we run from AWS to Google Compute Engine because it's really the best place to run our specific services. And this is a transition that I'm going to talk about later on that we're seeing in the vast majority of our customers. Things that used to run locally in their own data centers are now running in the cloud, or they're being run by someone else in their own cloud as delivered as a SaaS service. As you make that transition, how do you guarantee the performance and end user experience of your users that are used to some locally running application, 1 or 2 milliseconds of latency over your local network, to now something that's running effectively over the internet? You're now competing with 35% of the internet running inside of AWS. This seems like a wonderful transition. You're letting someone else do all the work to maintain these servers and make sure that they're working and working well. But when things go wrong, how do you actually troubleshoot these problems? How do you actually identify where problems are originating and what you need to do to fix them in something that's fundamentally someone else's network? You can't get SMP data outside your firewall. You can't get the type of insight really needed over the entire application delivery path for the cloud, but you're still responsible for end user experience when things go wrong. And that's really what AppNeta is designed to answer those specific questions. There's a number of different considerations you need to make when your organization transitions to the cloud. Obviously, is this the right choice for your business? If you know you're going to the cloud, you need to make sure you choose the right cloud provider. Is it a SaaS or platform as a service, infrastructure as a service? Is it public cloud, private cloud, hybrid cloud? What is their pricing model? Does that actually align with your business? If you're going to build the service you provide to your users on the cloud, does the pricing model of the cloud provider actually align with how you're going to receive revenue? Is it secure? This is a major question that a lot of people really don't focus on enough. But there's also technical needs. Do the cloud providers actually have the different services that you need to run your business? There's been major advancements over the past couple of years with the business process as a service offerings from these different cloud providers so that you don't have to run the databases. You don't have to run the load balancers, so that you can actually take advantage of storage and all these different services and really let someone else, rather than running your own databases, as I'll show you in one example, we run a huge number of sharded database systems on MySQL inside of AWS. We're transitioning to a service they call DynamoDB, so that someone else really runs those databases for us, make sure there's enough storage, make sure there's enough memory, make sure that everything is working well. And this is ideal, except when things don't work. All the logs that used to be available to us from MySQL, when things went wrong, simply don't exist. They're not accessible to you once you go to these business process as a service offerings. So again, this is a trade-off you're making. It's easier, it's faster, it's more cost-effective to go to the cloud, but you're giving up control and you're giving up visibility. And what we're here to talk about is how you get some of that visibility back. How do you make sure that your users are having a good experience as you make this transition? So there's really two portions to this conversation. From the users to the cloud over the open internet. This is the first challenge. And the second challenge is within the cloud itself. So we'll start with the first half, what seems to be the easy half. How do I actually measure performance from my offices, from my remote users, to where my apps are now running in the cloud? And then next, okay, the cloud itself should be relatively straightforward. How do we actually measure inside the cloud to make sure all the different nodes running my applications are actually getting the capacity I expect them to, the resources I expect them to? So the first choice is very, very simple and very straightforward. Choose the right cloud provider and explicitly minimize the distance between your physical users and the cloud data centers. People think the cloud is this amorphous thing that exists everywhere. That's not true. AWS has 13 locations globally today. Microsoft Azure has 19 locations. Google Compute Engine has 4. There are expansion plans, but really they're not that dramatic. You need to really minimize the physical distance between where your users are, where your offices are, and the right chosen cloud provider. Because something that you're running an app in your own local data center, you could have 1 or 2 milliseconds of latency going over your local network to that app. That sounds great. If you have an office on the West Coast and you choose US East for your cloud provider out of AWS, you've now introduced 40 milliseconds of latency on every transaction. And you've got a three-way handshake for TCP, you've got very chatty applications. The average application conversation for a web app has 19 different round trips to actually deliver the base web app. Something that used to be 19 milliseconds is now going to be 40 times that if you choose the wrong location. It's also 40 milliseconds to cross from the east coast of the United States to London, and to go from the west coast of the United States to Asia Pac. So you need to choose the right cloud provider based on where users are actually located. This is by far the most simple choice that people need to make, but it's often overlooked. People think, the cloud is everywhere. It's not. You need to make sure you understand that and understand that properly. So first takeaway, understand which data centers you're going to be running your services out of. The cloud providers do have the ability to do synchronization, both software and data synchronization between the two, so that if you've got different offices in different geographies, you can choose different availability zones and have everything synchronized. There's a cost to do that. You have to pay for multiple cloud deployments, and there's also a transaction cost. They do charge you for the data transmitted between the data centers, so you do need to understand that. But again, minimize the distance whenever possible. The next is make sure you really understand what the achievable performance into these cloud providers actually looks like. Because these are run by major companies. You think everything is going to be wonderful, but the problem is it's extremely congested within these services. So what we're actually looking at here is actual data from our office in Boston into both Google Compute Engine on the left and Microsoft Azure on the right. And generally they're doing pretty well. We're getting about 2 gigabits a second in each direction, both upload and download from our office into each of these cloud providers. But capacity isn't the only thing we need to really look at. In this case, we're seeing upwards of 16% packet loss into the Microsoft Azure data center. So this sounds wonderful. Everything should run quite well at 2 gigabits a second, but there's no guarantee that you're actually going to get the overall quality of experience you're going to expect. And this changes constantly. Just the internet, the nature of the internet itself, it's going to take the most efficient route possible to get from point A to point B. And within the cloud providers itself, if you go to AWS, you're sharing those resources with 35% of the internet. So you need to make sure you actually can measure this experience. Do it initially when you choose the right cloud provider, but do it constantly. You need to make sure you understand the performance in real time as things actually change, because things will change and they will change all the time. These actual yellow diamonds you're seeing on these charts are actually route changes observed on the internet between our office and into these cloud providers. So not only is the performance changing, the actual method, the actual route I'm taking to get into these cloud providers is changing roughly 200 times a day on average. So this is not a static problem. You assess it once and you're done. You really need to assess this consistently.
What kind of data were you sending? Is that TCP, UDP, ICMP?
So what we're actually looking at is our core product, PathView. And PathView is an active network monitoring technology where we send and receive a small amount of our own traffic. In this dual-ended scenario, it's UDP. And the actual methodology by which we determine the capacity and all these key performance indicators is called packet train dispersion. That's what our founder, Fred Clausen, he did this as his doctorate project to get his PhD, and founded the company based on this concept. And it's in use in over 10,000 networks today. It's specifically designed to send a small amount of traffic, about 20 to 50 packets a minute on average, from an instrumentation point at our end to any IP addressable endpoint. And by analyzing the distortion on that sequence of packets, we can determine what the achievable capacity is and these other key metrics about latency, loss, and jitter. It's designed to run in production, so you're not going to flood your network in order to figure out what the capacity is. We're going to use about 20 kilobits a second to actually do this instrumentation. But by really putting these packets in very precisely timed bursts, we're going to effectively stress the queuing and dequeuing on every layer 3 hop along the way to actually measure what is the achievable capacity and performance metrics to this hop all the way to that endpoint. So this is the type of visibility you're going to get when we have the ability to instrument at both ends, so we can see upload and download independently. This also works in a single-ended fashion. So if you can do a ping to that endpoint, we can do this in a round trip and identify what the bottleneck or choke point is between your source and the point where this you're targeting, even if you don't have the option to install something in the other end. So this is how we measure into SaaS providers. And we do this constantly. Yes? We're going to vary it. So we will detect what ports are actually open. So we will mimic a few different types of traffic. So for example, if you tell us you're going to be doing unified communications as well as data, we'll use a variety of size packets up to the MTU and a variety of ports to actually mimic the types of behaviors you're actually seeing there. So we're actually at booth 1108 if you want to see this running live, and I can go in depth on how this actually works. But this instrumentation is done constantly. We're doing a few different instrumentation cycles every 60 seconds, summarize it up by trending this over time to minimize false positives. And we store this data in the cloud, so you get 365 days of history. And just in the month prior to the show, I measured into all three major cloud providers and saw huge swings in actual performance, where into AWS we saw a minimum of 2.33 megabits a second from our location into AWS, and upwards of 16% packet loss into Microsoft Azure. So there's no guarantee this performance is going to be good, and it's going to change constantly. So you need to make sure you get what you expect, and that's that's delivered in a reliable fashion, because your apps are going to be something you're going to use consistently. A one-time test simply isn't enough to do this properly. And even within the best performing cloud provider, so as I said, Google Compute Engine only has those 4 locations to choose from, but they do an amazing job. They give you really, really solid network performance. In between the hosts running inside of Google Compute, you're going to get about 4 gigabits a second of performance. But you're also going to get about 2 gigabits a second from high-speed remote locations into Google Compute. They do this really, really well. We've never actually seen packet loss. We've never seen issues with retransmit rate into Google Compute, but they're not perfect. And what you're actually seeing here is a network failover we observed, where the 2 gigabits a second I was expecting for my users actually was cut in half for about 3 hours, and we can actually see the ISP went from Google to DataPipe. It actually went to their failover provider. Google is very good at what they do, so there's no actual packet loss observed. This happened basically instantaneously, but the actual achievable capacity was cut in half, and the latency and round trip time quadrupled when they went to this backup provider. So it's simply not as efficient when they're using this backup, but it's really a function of, I'm not down, I didn't actually lose any traffic, but the actual achievable performance to my users and my applications was cut dramatically. And this is something cloud providers do really, really well. We actually do real-time transaction replication across availability zones in cloud providers to make sure if our primary goes down, just do automatic failover to the backup so there's never any downtime for users. But there's no guarantee that the performance I get on that backup is just as good. This is a clear indication that even the best cloud provider in terms of network performance, Google Compute Engine, is still not perfect. And this is really the next takeaway is, when you go to the cloud, if you architect your app well, you can really minimize downtime. But you do need to make sure that the performance is there. You're going to get what you expect, because if this is a service you offer to your customers, they can just take their click somewhere else. They can shift off you quite easily and quite rapidly. And this is what we call slow is the new down. You can avoid downtime with a properly architected application, but understanding the actual achievable performance to that is a very different question and needs to be looked at with the right set of tools. We've covered briefly how to actually measure performance to the cloud. Now, measuring inside the cloud seems like it should be very, very simple, very, very straightforward. If I run something in a VPC in AWS, I have my own little virtual network. I'm the only one on it. Everything should be really simple and very straightforward. Not the case. All of these cloud providers run very, very complex software-defined networks. And I know there's a couple of other sessions today about software-defined networks and how wonderful it is. It also means you really have no visibility into what is the achievable performance over that software-defined network and how it's actually running at any given time. Those physical devices you used to be able to point your finger at are now gone, and there's some algorithms determining how does the data get from point A to point B. If you're just running your own software-defined network, you could potentially wrap your head around it. Inside of AWS, they just don't give you this data. Inside of Google Compute Engine, they don't give you this data. You can't figure it out on your own. We've actually have an entire product set designed for people running apps inside the cloud, and we built the network instrumentation we were just looking at into the cloud instrumentation. So if you have an app running in the cloud, we will automatically determine the network paths taken between these hosts and tell you what the achievable performance is. And this is really critical as people take apps to the cloud. You need to really take advantage of it. Just taking a monolithic application used to run in your own data center and moving it to the cloud isn't really going to do anything. You're still running that app on one VM or one host. To really take advantage of the cloud, you need to use the technologies available. And the biggest trend we've observed within our customers is a transition to microservices. So you're taking an application that used to be one big monolith, you're breaking it up into a number of services that can be reused across a large number of applications. And this does enable you to measure the performance of discrete business transactions and scale the resources available to any number of different components independently. So if you know this part of your application is very, very meaningful to me, say it's a checkout process in an online business, I can throw a ton of resources at that specific microservice, whereas other ones, which may be not as business relevant to me, I don't need to allocate because I can scale them independently now when I transition to microservices. This is not just something we see in startups, people developing from scratch. This was a story in the Wall Street Journal back in February. Goldman Sachs is going to Docker. They're converting 90% of their own internal software deployments. They have several thousand developers. They're converting all their apps to use Docker to go to microservices. So you can scale them independently to really optimize the performance and availability of your app. So this is being used by small startups in a garage somewhere and the largest companies in the world. This is a transition that is really happening. This sounds wonderful. You can scale these nodes independently, make sure you've got the optimal utilization of these resources, but now you've taken something that is code that used to run on the same physical host or same virtual host, and you've broken it up, and you've introduced it on different hosts, and now there's a network in between them. How do you actually make sure that that function call, that API call, that used to just run on the same box is now able to get the same type of performance now that it's running on different hosts within a cloud provider environment. And a great example of this is we have a large customer who's a major marketing website. You may think of them as, this is one website. I use this service, I go log in there, I see what's actually happening, I can understand the performance of my different campaigns. When you look under the covers, it's actually 175 microservices that they scale independently. It's very, very complex. It's changing all the time. They do on average 200 deploys a day, so this architecture is changing constantly. And what we're actually looking at is what we call an app map, identifying the different nodes, how they're actually communicating. And this is actually just the login process. If I were to log into this service, that's not one machine that's being hit. It'll loop back in just a minute. It's actually 6 different hosts that are all talking to 27 different caching systems and database systems. And there's a network in between all of those. I need to understand what is the actual achievable performance running inside of AWS or my chosen cloud provider so that I can see, okay, my logging into this app, it's not very simple, it's not very straightforward. It's extremely complex, and now I can get data from Google or AWS to understand what is the memory utilization on that host, what is the CPU, what are all the key metrics about the host that it's specifically running on. What I don't understand is what is the network performance between that host and that database, and that's really where we come in. We'll automatically discover how your apps are architected and do the network instrumentation automatically for you so that we understand that you're making an API call to that network system, you're using Google Maps, for example. We'll actually know that you're making calls to Google Maps and actually measure the network performance to Google Maps and do that sort of instrumentation automatically. So your app map is always up to date for your architecture and the performance available. So this trend of apps becoming more distributed is, it's real. It's occurring everywhere, from small startups up to Goldman Sachs, as shown. And as soon as you make that transition to microservices, to Docker, to all these different containerization options, You've now taken something that used to run locally, broken it up over multiple hosts. Well, that's just more complex. There's a network in between things. You need to understand the achievable network performance inside that cloud provider. And that seems like it should be really simple, really, really easy. I go to AWS and I buy a VM. The most common VM they sell is an M3 extra large. I get so much CPU, I get so much memory, I get so much disk I/O. I get a gigabit connection, right? That's what it tells me. That's what I should get. That's not true. When you actually read the fine print, an extra large instance, you're guaranteed 62.5 megabits a second. So you've taken this app that used to run locally in your own data center on gigabit or 10 gigabit networks. These function calls used to run locally on a PCIe backplane in between on the same physical host. It's now broken up over multiple containers running in the cloud. This should work perfectly well. No, it's actually an option. You have to pay extra for high performance networking within all of the cloud providers. This is something that most people don't actually understand, and you really need to if you're going to make this transition, because the performance in the cloud is quite challenging in a number of scenarios. So this is actual production operations. This is one of the AppNet SaaS services we run, and we're actually taking a look at one of our, this is a Python application, talking to remote databases. So we shard the databases for security and performance reasons, as you might expect. So in this case, we're talking to 82 different remote hosts. 7 of those were having extreme packet loss. So this isn't a problem with the original host running Python. This is a problem with that sharded MySQL database. And there's 8 hops within AWS, that software-defined network. And they're doing generally a pretty good job of getting 2.2 gigabits a second. Very low utilization, but we're seeing upwards of 8% packet loss, even within AWS. So you think, okay, I get a gigabit connection, not true, and I'm just on a local network inside of this cloud provider that does a wonderful job. This should just magically work. That's not true. This is a case where I'm paying for the high performance networking to go from that 62.5 megabits a second up to 2.2 gigabits a second, but I'm still seeing 8% packet loss, which is going to kill the performance of a web application. If you have 5% packet loss on a web app, a page transaction will take 4 times longer than it would normally. So this is something that will kill the user experience with an app when you go to the cloud, and it's something that simply you can't get this data from CloudWatch or any other from any of the cloud providers. They're not simply measuring the performance between all different combinations of hosts. We do it automatically based on your instrumentation, and it's automatically up to date. As your apps talk to each other, we'll build up and tear down these transactions automatically. So this is this is a challenge that a lot of people don't really know and don't really understand. That I should have a gigabit connection inside the cloud. Not true. And you're competing with traffic with with thousands of other users, tens of thousands of other applications. So these apps are the cloud infrastructures are extremely complex. They generally do a good job. The area where they're not really focusing, and it's just indicative of within what you pay for, they don't guarantee the network performance, and the actual network capacity they give you is a fraction of what you think it is. You need to really understand that when you make this transition. So just to do a quick summary, as you make a transition to a cloud provider, or if you are choosing a SaaS provider, these options are often are relevant as well. You need to make sure you understand where your users are and choose the right geographically centered cloud data centers to minimize that distance. It's 40 milliseconds to traverse North America. It's 40 milliseconds to traverse East Coast to Europe. It's 40 milliseconds to traverse West Coast to Asia. So if you're choosing the wrong geographically distributed data centers, you can take something that's performing quite well locally and make it extremely painful for users if you choose poorly. The performance to cloud providers does vary widely. They generally do a good job where, if we were to dive down into what actually causes that packet loss, we observed within Microsoft Azure, that was actually an overly aggressive layer 7 firewall. They're trying to really beef up their security. They do packet inspection and try to identify trends and threats overly aggressive with how they enforce that security, and it can actually have a major impact to the achievable performance into that cloud provider. And even if a cloud provider is up, that doesn't mean it's actually performing well. There's a scenario and a symptom we've observed within AWS, but it's actually relevant to other providers as well, called the bad apple syndrome. And all the different cloud monitoring systems will do this for you now. When you spin up a virtual machine, they'll actually test memory, CPU, storage I/O, and say, okay, is this host actually giving what I expect? Or is it suffering because of what they call the noisy neighbor syndrome? Your VM may be next to some very, very popular site on the internet. The resources you expect to be there are going to be starved. Well, they can't actually measure the performance between the nodes of your app because they don't know how your app is architected. You need to make sure you understand that properly and make sure you get what you expect within these different cloud providers, because they can keep your app up and running. That doesn't mean it's going to perform well. And within the cloud, you need to make sure you understand as you architect your application to take advantage of cloud services as business processes as a service. Every step along the way, it becomes more fragmented. You're going to containers, you're going to BPaaS services. It's wonderful that someone else is going to manage these hosts for you, make sure they're up and running, but you've now introduced a network between nodes that used to be on the same virtual machine. And as we've seen, the network within the cloud is not guaranteed. You don't really get what you pay for unless you pay for the premium option. And even when you do, the performance available to your app can vary quite widely. And if you don't pay for that premium option, the performance available to your VMs is actually going to be quite low. You need to make sure you understand that properly. So this all seems great. You need to make sure you understand performance. You need to measure constantly. Are there downsides of doing this continuous monitoring? Well, there are no downsides. That's not true. There's a slight amount of overhead when you do actually do this instrumentation. To actually get the performance insight we were looking at with these different instrumentation points, if you can install something at both ends, that's ideal. You need to make sure UDP is open, and you're going to see somewhere between 20 and 50 packets per minute to actually get all these metrics. If you're doing single-ended monitoring into something like Azure, they specifically block ICMP traffic in. So you need to make sure you can get something at both ends to get the ideal visibility. And within the cloud, if you want to make sure you understand the performance between the nodes, there is a slight overhead, about 0.5% on those running nodes to really understand what is actually the host metrics for CPU and memory and everything else, but also understand network performance between where your code is running and remote services like BPaaS services. So there's a slight overhead to doing this, but this is really designed to give you a lot of that visibility back. That when you went to the cloud, someone else is going to run that for you. You're taking hosts that you used to manage yourself and letting pure experts, the people at AWS and Google Compute Engine and Microsoft Azure are really, really smart, and they do a wonderful job running these data centers. But they really don't know anything about the apps you're running, or if the user experience of your consumers of those apps is any good. It's their job to make sure that they're running, not that users are happy with the performance. When you make that trade-off, you need to make sure you do the right instrumentation to understand, are your users actually happy with the performance? And is that performance being delivered consistently? That's really what we're here to do. So with that, I'd like to open the floor up to any questions about how we actually do this instrumentation and how you can best take advantage of it.
Do you do anything with the vendor, like we would purchase software service from, or HRIS, and they're actually using AWS as their host site. So would you be able to provide that information to us as a customer of the HRIS payroll package?
Yep, absolutely. So this is designed, and probably 80% of our customers are the consumers of applications that they have developed themselves. They just need to know, my business relies on this web application. I need to make sure that it's working and working well. We can absolutely instrument from your network over your wireless connection, over your WAN connection, to wherever that app is hosted. We can, and we've proven we have visibility into all cloud providers, so that we can tell you what that experience is to your actual offices, even if you can't put something at the other end, it works perfectly well.
So have you ever been part of an evaluation of 3 vendors that were all SaaS, and you ran it for a week, as an evaluation piece.
Yep. That sort of cloud, we do this constantly when people are choosing, okay, which cloud provider am I going to use? Because it used to be pretty much a moot point. AWS is so much bigger than everyone else. Google Compute Engine has done a wonderful job in the past 2 years really catching up. And people want to verify, okay, which service am I going to use for this cloud provider, as well as other SaaS providers. There are options out there. People know if I'm going to take something that I used to run myself locally and let someone else do it for me, I need to make sure that my risk is minimized and my users are going to be happy with that performance. We can absolutely test to multiple providers at once and tell you what the achievable performance is to either a cloud provider or a SaaS provider from all of your different offices. That's something we do regularly. Any other questions?
Are the cloud providers responsive to representation of issues and SLA enforcement?
If you read exactly what the terms of service are for the different cloud providers, there's no guarantee about network performance in their SLAs. But yes, they are responsive to us. In fact, the cloud providers are actually customers of ours because they don't like their end users having more data about the available performance than they do. And we have versions of this. When you use the service, we give you a physical appliance to run in your offices. We also have virtual versions of it on VMware, OVA, and KVM, so that we have versions that run in all the cloud providers that they're using themselves to measure performance, and you can use bidirectionally to test from your locations into the cloud. So Microsoft Amazon AWS is a customer of this, specifically because they need to understand the performance they're delivering to their end users as well. So we absolutely have these conversations with them regularly about the actual performance available, and this is a SaaS service that we offer, and we actually have performance engineers that can help you go to bat with your ISP or your cloud provider if the performance they're giving you isn't any good. Any other questions?
Is this primarily using flow view data for the analytics?
So everything we've looked at here is not using flow. It's not using any device-centric information. So we don't need to get SNMP. We're not getting WMI from Windows machines. We're not using IPSLA. We're not receiving a NetFlow stream to do this. We do have the option and the capability in the service to analyze raw network traffic, do DPI analysis to identify what apps are on the wire. But everything we've looked at here is an active network instrumentation technology using ICMP and UDP packet trains to actually stress the queuing and dequeuing process on layer 3 hops to actually measure what is the achievable performance at layer 3 and layer 4 over any network from where the app is being consumed to where it's being delivered. So we don't need SNMP set up, we don't need NetFlow set up. We're going to basically just be another client on the network sending our own traffic. And that enables us to measure the performance, but also follow those routing changes. So as the routes change, we will automatically follow it because we're just another app on the wire. But the point of our app is to measure the available performance of it. And that's why it can work on the open internet, because we're not dependent on device data to do this analysis. Okay, any other questions? So I know there's a lot of data here. Those were videos of the actual product running live. We've got it back at booth 1108. If you guys want to see this in person, you want to see how we can, and we can actually add targets to whatever you'd actually like. This instrumentation is designed to work anywhere, and we've got a live production system running in the exhibit hall right now. So with that, I'd like to thank everyone for their time.